Hi everybody, welcome back to the Feynman technique. Today we're going to be finding the value for any integral expressed in this form. That is the integral from 0 to infinity of some function of x, f, evaluated at the point a times x minus that same function evaluated at b times x over x dx. Um, and our first step is going to seem a little strange. We're going to consider a new function g of t that's equal to this integral right here. So this is a new function g, not well, somewhat related to our function f, in that it depends on our function f, but it's equal to this integral right here. All right, next step is let's consider this new function g evaluated at the point natural log a. So g of natural log a is going to be equal to this, because you'll notice we're just replacing our t with natural log a, and that's going to give us this f of ax minus f of 0 over x dx. And let's do the same with natural log b. If we plug in natural log b for our t, we just get f of b minus f of 0. All right, so why did we do that? Well, because now if we subtract natural log g of natural log b from g of natural log a, we end up with this integral. Because if we subtracted these two integrals, these f of 0 terms would cancel out. So we'd be left with nothing but this. And you'll notice that's exactly the integral that we are trying to find. So if we can find a generalized expression for g of t, and evaluate it at natural log a and natural log b, we have our answer. All right, so what's the next step now? Next, we're going to take g prime of t. We're going to take the derivative of this function with respect to t using the Leibniz rule for differentiation under the integral sign, which says that we can just take the derivative of this function right here directly, simply by taking the partial derivative of the integrand. And what's the partial derivative of the integrand? Well, we'll have to use the chain rule here. Don't forget we're taking the derivative with respect to t. So this is going to be f prime of the inner function times the derivative with respect to t of the inner function, of course, which would just be x times e to the t. And this minus f of 0 over x would drop out because that's constant with respect to t. So we end up with just this. We'll just have f prime of e to the tx times e to the t, because you'll notice those x terms would just cancel out. All right, so there's our g prime of t. All right, let's make a substitution now. We'll just let u equal x times e to the t, which means our du is e to the t dx. All right, so this is going to become u. This is going to become du. And our bounds of integration will not change. So all we're left with is just g prime of t is equal to the integral from 0 to infinity of f prime of u du. And using the fundamental theorem of calculus, that's just going to be our function f at infinity minus f of 0. So there's our g prime of t. Great. What now? Well, we can get back to g of t by taking the antiderivative of g prime of t. And that's, since this f of infinity minus f of 0 is just a constant, that's just going to be f of infinity minus f of 0 times t plus c. And now, okay, so we already have an expression for g of natural log a minus g of natural log b. Let's see what it turns out to be if we just plug it into this function right here. Well, that's going to give us this whole thing, at natural log a minus this whole thing at natural log b. So we end up with this minus this. And of course, you'll notice that these constants of integration, they will cancel out, and that's just going to give us this. All we're going to be left with is f of infinity minus f of 0 times natural log a minus f of infinity minus f of 0 times natural log b. And using the properties of logarithms, that is just going to give us f at infinity minus f of 0 times natural log a over b, and we are done. Because don't forget, this was equal to the original integral right here that we were trying to find. So, in conclusion, any integral of this form, the integral from 0 to infinity of f of ax minus f of bx over x dx, is just f at infinity minus f of 0 times the natural log of a over b. All right, guys, I hope you enjoyed that, and we'll see you next time.